program. In that program, we have created one class student with some properties and one static member, that is the institute name. We have created the default constructor with default values for those instance variables. Then, as I said, if you want to perform any operations on instance variables, you have to create that method. You have to create a method which will be the instance method. So this method we have created as instance method. Okay. And if you want to access any static member, you can create that method as static method, because there is no point creating that method as non-static method. Okay. So instead of that, you can create the method as static method. Then in another scenario, that suppose I want all the information of the instance variables as well as the static variable also, then you can make one instance method where we are getting all the details of all the instance variables. The method name I am using as get complete student info, and I'm adding one more statement, that is institute name also, along with all the instance variables. As this method uses instance variables, that is why you can create the method as instance method. Okay. So basically in instance method, you can access instance variables as well as static variables. Okay. So you can create static method for accessing only static member itself. You cannot access the non-static member here in this method. Okay, because static member is accessible within the static member. Okay, non-static context or non-static members are not accessible from the static context. Okay, so this is not accessible from the static method. So if you want to create any method with the instance variables and static members, then you can create that method as instance method. Okay, now these are different methods. Okay, suppose I want to create one more method that is for calculation of average marks. Okay, so that method average marks, which will have parameters. Suppose the parameters are I am giving the method name calculate average. Okay, this average method will have two parameters, which will be the marks. Okay, so you can use 2 parameters, 3 parameters, whatever parameters you want. I am going to use 2 parameters here. Okay, that will be a double type. So first double n1 and double n2 are the 2 parameters I am using here for this method. Now this method is calculating average. This method is calculating average. Okay, so this calculating average is totally based on these 2 parameters passed. It is not going to use any of the instance method or any of the static member. Okay, any instance member or static member. It is not going to use any of these. It will only use the parameters passed. Okay, then if that is the case, calculation of the average will be same for all the past parameters, right? Whatever the parameters gets passed, the calculation will be different, but that is not depend on any of the instance method, right? ये कोई भी instance members पे dependent नहीं है. ये पूरा आपका dependent है आपके parameters जो भी आते हैं इस method को उसके ऊपर. तो इस अगर ये scenario है तो that time you can create that method as a static method itself, because it is not necessary to create it as a instance method. इसको instance method बनाने की जरूरत नहीं है. क्यों नहीं है? क्योंकि ये method कोई भी instance member use नहीं कर रहा है, instance variables use नहीं कर रहा है, and calculation is totally depend on the members passed. So there is no need of making this method as instance method. You can create the method That is, this method is going to return double value. So I am giving the double data type, and the method will be static. Static double calculate average. Okay. Now this method will return calculated average. So that is, suppose n1 plus n2 divided by 2. Okay. I'm calculating average. Whatever the calculation part will be there, you can write it down. Okay. So इस मेथड में हम कोई भी इंस्टेंस मेंबर यूज नहीं कर रहे, इंस्टेंस वेरिएबल्स यूज नहीं कर रहे. इट इज नॉट डिपेंड ऑन एनी इंस्टेंस वेरिएबल. कोई भी मार्क्स वेरिएबल के ऊपर वगैरह डिपेंडेंट नहीं है. सो अगर इस तरीके का सिनारियो आपका है जो इंस्टेंस वेरिएबल्स यूज नहीं करता है, बट आपको कुछ कैलकुलेशंस परफॉर्म करने हैं, तो इस मेथड को आप स्टैटिक बना सकते हो, सो दैट इट विल गेट मेमोरी allocated only once rather than getting different memory allocations for different objects. ठीक है. सारे डिफरेंट ऑब्जेक्ट्स के लिए डिफरेंट मेमोरी allocation करने की जरूरत नहीं पड़ेगी अगर ये इस तरीके से आपका मेथड है कैलकुलेशन करने के लिए, तो आप उस मेथड को स्टैटिक बना सकते हो. ठीक है. तो इसको एक ही बार मेमोरी एलोकेशन होगा, इसको आप एक्सेस कर सकते हो विद द हेल्प ऑफ नेम ऑफ द क्लास. Okay, now we have created this two objects, right? S1 and S2 object. So this I will add here. This is the static method. Okay. S1 and S2 object we have created. We have called the get institute name method as well. Now we will call S1 dot get complete student info method, where we are getting all the information of student. Whose information? The object S1 object's information. Similarly, we call the same get complete student info method from with the help of S2 object. So we will get all the details of S2 object. So here the institute name will be same for all both the objects because it is, we have not changed it. Okay. If you are changing the value, then you will get the updated value for both. So here I am adding some lines to just to understand the output. Okay. We will execute this. Run a Java application. You can see this is the first S1 object. We got the roll number, name and marks value. This is the S2 object जहाँ पे हमने values set किए थे, वही ये values आपको मिल रहे हैं. Institute name, accessing the static member from static method. Again complete institute info method call किया है जहाँ पे static member के साथ यहाँ पे आपको value दिख रही है. ठीक है. ये static variable हमने instance variable के साथ access किया है. The value is same for both the objects. Right. Now we will call this calculate average method. So this is a static method. So we will call it with the help of class name. I'm passing two values here. One is 63. Second one is 94. Okay. So this calculate average is going to return the value. So this value should be saved somewhere in any variable, or you can directly display the value also using if it is necessary. Okay. So I'm finding average is equals to, I'm calling this method and passing two parameters. So this calculation is totally based on the two parameters passed. Okay. So I'm adding here average 2 with values. I'm changing the values here. Okay. So it is totally depend on the values you are passing. Okay. So it is not using any of the instance variables. That's why we have created this method as static method. Java application. So you can see the first average and second average. It is returning double data type value. So we are getting the values in points. Okay. So this is, in this way, you can identify which method should be created as your instance method, which method should be created using the static keyword. Clear? If you are changing the value for here after get institute name, I will change the value for institute name. Okay. Directly student dot institute name is equals to, I am changing it to suppose XYZ technology. Okay, so if I am changing it, so we will get the same changed value for both S1 and S2 objects because it is shared resource and it is changed for both. So whatever the number of objects you have created, it will be changed for all the objects. Okay, but here get institute name method was returning Stu Valley because we have changed the value later after execution of this, right? So as per the line by line execution, after the execution of this statement, your value gets changed for all the objects. Clear? Any doubt? So understood when to create the instance method and when to create the static method. So most probably, whenever you have any calculations in your program, that method should be created as static because there is no need of creating the calculation part if that is not using any instance variable. Then you should create that method as static method so that you can save the memory and the memory will be allocated only once. You can access it using the name of the class directly. You don't have to create the instances of that class. If it is using any instance variable, then you have to create that method as instance method. Okay. For example, instead of this N1 and N2, I am using marks variable here. Then I should be using, I should declare this method as instance method, removing the static context because the mark instance variable is non-static. Okay. And in the static method, you cannot access it. I will show you that marks divided by 2. If I am doing this, it will give you error because you can see here cannot make static reference to non-static field. Okay, so non-static fields are not accessible from static context. That's why if you are using this marks variable for calculation of average method, then you should make that method as instance method. Clear? Understood? Any more doubts? Go through this example once, complete example, and let me know if you have any doubts in 2 to 3 minutes. After completion of going through this example, we will start with the next points.
So overall, static variables can be shared throughout the program. And if at all we are changing it, it's going to affect the original value.
Yes, because the memory allocated it only once, right?
Only once.
That
Yes.
is the thing. If you are updating that value, then it will be updated for in that memory allocation itself. And that is shared among all the objects. That's why you can say that it is updated for every object.
So presently we are there in the single class. So that's why we are directly using this institute name. Otherwise, class name dot institute name should be used.
Yes. So
Okay.
here this class student is different and we are accessing the institute name here with the help of the student class name.
Okay.
I have defined this method just to get the value of institute name. Okay. So that is why I'm using directly the institute name itself. So if you are accessing the static member in the same class, you can access by using name directly. It can be variable or method as well. That is not only for the static members. You can use non-static members also in the same way. You can access the variables and methods if those are defined in the same class. You can access it directly with the name. So here we have updated the name. So it will be updated for, we have created two objects, so it will be updated for both objects. Okay, we'll go forward. So we have seen that static methods can be accessed using its class name. No need to use object of that class to call it. Static methods can be overloaded. Okay, so you can overload the methods, but static methods cannot be overridden. Overloaded means you can overload the same method. Overloading, you know that, right? So this is a calculate average method. So I can overload this by changing data type or parameters. Okay, so I'm changing here, adding here double entry variable. Okay, so you can overload static methods, can be overloaded. Similar to this is a main method which has a static reference, right? And the type signature is already defined, that is static void main string array arguments as a parameter. You can overload the main method as well by changing the parameters. Okay, suppose you are giving the same name, public static void main, but you are changing the parameters only to string s, then you can overload the main method as well. Okay, so this is the part where main method also we can overload. Because most of the time students never understand that main method is not whether it is overloaded or not. So the basic thing is main method is defined as static, and static methods can be overloaded. So you can say that main method also can be overloaded, but this will be the standard main method signature which you cannot change. Overriding concept we have not yet seen. So when we see the overriding concept, I will explain that why static methods are not overridden. Okay. So if you define the same static method name with type signatures in subclass, same as superclass, then one of the method will get overhidden. Okay. This concept we will learn in the inheritance. So you will understand this point in inheritance. So we have already seen the common behavior for all instances should be written inside the static method. Clear? So first we will see the difference between non-static and static method, because from non-static method you cannot access static method, and from static context you cannot access non-static context. That is why the difference will be there. So for non-static, it has own copy of every instance. As a static method, it has a single and shared copy among instances. Non-static method is also known as instance method, and static method is also known as class method. Okay. Non-static method is loaded dynamically when the new object gets created. So unless and until you are not creating any object, तब तक इसको memory allocation नहीं होगा. That's why non-static methods or instance methods gets loaded dynamically when the new object gets created. But in reverse, you can say that static methods loaded statically along with the class, because the static members gets memory allocation at the class loading itself, right? Non-static method, it is accessed using object of the class, Now, a static method, it is accessed using class name of that class. Okay. Then the memory will be allocated every time when new instance is created, and static member के लिए memory only once allocation will be done at the time of class loading. It can access static variable and instance variables directly, as we have created one method get complete info here, which is accessing static member as well as instance member. Okay, so non-static method, that is the instance method, can access both thing, that is static variables and instance variables. But in this in the static method, you can only access static members only. Okay, that is static variables directly. You cannot access non-static. Then non-static method call to the static methods and instance methods directly. We can call the methods from instance methods. Okay, but in the static method, you can only call other static methods directly. You cannot call non-static methods. Then non-static method uses this and super keyword. We have used this keyword in the instance methods, right? We have used this keyword in the instance methods or constructors. You can use those here also in the this dot roll number, this dot name. Okay, instance method also uses this keyword and super keyword. We are going to learn the super keyword in inheritance. Okay, but in the static method, you cannot use this and super keyword. I will show you the use of this here in the static method. This dot institute name, you will get the error because static method never uses this keyword. Why? Because this is always pointing to the current object in reference, current reference, right? So that is why we cannot use this and super keyword in static method. Non-static method can be called using this or super keyword. Same, it cannot be called using this or super keyword. So using this keyword, if I want to call the instance method, you can call it. Suppose here, instead of all these things, I want to call this method because everything was there here. So I can replace this part with using a single statement that this dot get student info. So this here we are using this keyword to call current objects get student info method. Okay, so using this you can call the instance methods as well. So it will go to this statements, it will execute these statements and come back here and execute the next statement. So there is no need of writing the same statements again in this method. Okay, so you can use this keyword to call instance method also, but you cannot use this keyword or super keyword from the static method or for calling the static method. Okay, clear the difference between non-static and static method? Any doubts? Okay, so we will go forward. Next is last part for the static keyword. The last part is static block. We have seen the anonymous block, right? Similarly, if you want to initialize the static members, then you can create the static block. That is, the block will have the name static, or the keyword we are going to give to that block will be static. You can write any code inside that. So it is executed before main method at the time of class loading because the memory will be allocated for it and it will get executed only once. Okay. So static block is also used to initialize the static data member. So before main method, it gets executed. Okay. So we'll create one example here. In the static keyword, I am creating a new class. Static block example. Include the main method. Here, we are going to define the static blocks in the same class. So you can define the static blocks with the help of static keyword and then the block of code. You can write anything inside this. So I'm writing one statement, system.out.println. First static block executed. Okay. First static block executed. You can write any code also, like suppose here, second static block executed. It will get executed in the same manner which in you have written. ठीक है, जिस सीक्वेंस में आपने लिखा है उसी में वो एग्जीक्यूट होगा. ठीक है, उसी सीक्वेंस में एग्जीक्यूट होता है. तो सपोज आई एम क्रिएटिंग एनी वेरिएबल हियर, n is equals to 20. I want to find out whether this number is even or odd. N mod 2 equal to 0. I will write down system.out.println. N is even and else n is odd. Okay, so basically you can perform anything. If you are creating any variable inside the static block, it is by default static. Okay, it will be by default static. You don't have to give the static keyword here externally. Implicitly it will understand, it will create this variable as static. Only thing here is this is the second static block we have created. We will execute it. We don't have to call it. It will get executed automatically. Okay, it will get executed automatically. You don't have to call the blocks, like, or you don't have to access it. It will get called automatically. Okay, so here these two I have created. So mostly this static blocks are used to load the library files. Okay, so if you are developing or added any new library files which is required for your application, you have created that and you want to load it. So before main method, it should get loaded. That is why we use the static blocks to load the memory, to load the library files. So here I am showing you one statement how to load the library. So we have a system class. In that we have a method load library. Here you have to pass the library name. Library name is nothing but any jar. If you have mentioned any jar, you have created any jar file and you have added that in your project. So that jar name you can give here. For example, here I am giving native library path. Okay, whatever the path will be, you can give that path here. Using the load library method, it will load that library files first, and then it will start executing of your, then you can execute the project, or if you can execute your application, you can use whatever you have written in your library files. Okay, before loading it is not possible. अगर आपने ये JRE इंस्टॉल ही नहीं किया है तो आप प्रोग्राम नहीं कर सकते हो. क्यों? क्योंकि सारे लाइब्रेरी फाइल्स, जावा रिलेटेड सारे क्लासेस जो भी पार्ट है वो सब कुछ JRE में डिफाइंड है. राइट, अगर आपने JRE इंस्टॉल ही नहीं किया तो आपका एग्जीक्यूशन नहीं होगा. सिमिलरली अगर आपने कोई लाइब्रेरी बनाई है तो उसको पहले लोड करना पड़ेगा आपके एप्लीकेशन में. तो लोडिंग इज मोस्टली डन इन द स्टैटिक ब्लॉक, क्योंकि स्टैटिक ब्लॉक as we have seen it gets executed before main method. ठीक है, सो स्टैटिक ब्लॉक पहले लोड होता है, एग्जीक्यूट होता है मेन मेथड से पहले. दैट इज वाई स्टैटिक ब्लॉक में हम मोस्टली लाइब्रेरी को लोड करते हैं. How to load the library? Using the system classes load library method, and you can provide your library path here. So it will get loaded first in your application project, or you can use whatever you have written, the library files you can use in your application directly. Okay, after loading. So this is the use of static block. Before this, you can call the other methods as well. Suppose I have written any method with static void m1 is the method. Okay, this is m1 method. I have written one statement, m1 method call. Suppose there is one more static block. This will be the third static block. From this static block, I can call M1 method. Okay. So basically, static block, you can write complete program also in the static block. Whatever you want to do, you can write it down. If you want to create any object, you can create the object also. Suppose I want to create the object of this class after calling M1 method. There will be, suppose, one instance method. That instance method is M2 method. Okay, this is static method. Okay. And M2 method is instance method. So if I want to call this instance method, I have to create the instance of this class, right? So you can create the instance of the class. This is static block. Class name is static block. Static block example S is equals to new static block example, and you can call S dot M2. Okay. So you can create objects also. You can call the instance methods also inside the static block. I will execute this. So you can see this was the first execution. This is the second static block, third static block execution from where we have called the M1 and M2 method. Okay. So these basically you can perform any code inside static block. Then you will say that what is the purpose of writing this main method or this class? Then you can do everything in the static block, right? But now main method is compulsory. Before, in the previous version, if you are not writing the main method and you are writing everything in the static block, it was allowed. But now writing the main method is compulsory. You have to write the main method compulsory to execute it. If you remove this main method, this class will never work. Okay, you will not get any option to execute this. Okay, so nowadays it's compulsory to write the main method, but in older versions, you can skip writing the main method and you can write everything in the static block. That was part. Okay. Any doubt? Understood? Clear? So basically you can perform anything. You can write any code inside the static block. So first I will execute, open this system class. So you can see that system class has this static block, which has one method, that is register natives method. So basically this register natives method is used for registering all the native, that means related to your system. Okay, all the things related to your system. Okay, so it is using this method for it is gets called into the static block before executing anything. Okay, so system class calls uses the static block to register your native libraries. Okay, so there are multiple static blocks written in whole Java, okay, which are used for loading the libraries and all things. I have just shown you one part. Okay, clear? Understood? Any doubts, anyone? We are writing the static blocks inside the class itself. Okay, you cannot write the static block outside the class. You cannot write it. You have to write the static block inside class. Now we will do one more program where we can write the static block, anonymous blocks together so that you will understand that how the execution will be done. So we'll create one class in the module 8 package. Static block with anonymous block. I'm including the main method. So suppose we will create one class named rectangle. This rectangle class has two members, instance members, integer, length, and width or breadth. You can give any name. Okay. So I'm using length and width. I will create one anonymous block to define the length default value. So anonymous block 1. System.out.println. We will display that statement also. Anonymous block 1. Here I am going to set the value for length instance variable to 10. Then I will create one static block. We will write down the statement static block 1. And we will add the lines also just for your understanding. The output. I will add line at the end of both. Okay, so this is nothing but the anonymous block. This is a static block. Now we will create one more parameterized constructor, default constructor for this rectangle. This is a default constructor. We will write the statement. This is default constructor called. Okay, this is the default constructor. In the default constructor, I am going to set. Okay, we will not set anything. We will simply write down the statement. Okay, I am not initializing any value. We'll create overloaded constructor rectangle itself. Now we will generate it. So using source, generate constructor using fill. I just want to generate one constructor with length parameter. Okay. This dot length equal to length. Okay. It is by default. And I am adding one statement that is system.out.println parameterized constructor with one parameter. With one parameter. We will generate one more constructor with both parameters. Okay. Show this super. We'll add the line and the statement also. With two parameters. Okay. So here we have created class rectangle, instance variables, length and width, first anonymous block, first static block, then default constructor, constructor with one parameter, constructor with two parameters. Okay. Now we will create one more anonymous block. Okay. We will create one more anonymous block. I will copy this. Anonymous block 2. Value I am setting for width. This 10 and this. Okay. Now we will create one method, area method. Public void area. Here we will simply calculate the area of rectangle. Area of rectangle is equals to. Now we are going to use the instance variables. That's why this area method is instance method. Okay, so we will use this dot length into this dot width. Okay, length into width is the calculation formula for calculation of area of rectangle. Okay, so basically we have created one static block and two anonymous block. So whenever you are defining static blocks and anonymous block, the sequence of execution is static block gets executed first, because before main method the static block is going to execute, right? So static block gets executed first, and whatever the statements of the anonymous block 1 and 2 will be copied for every constructor, right? So basically these two anonymous blocks gets called 3 times, because we have defined 3 different constructors. Okay, so we will create the object for this rectangle class. R1 is equals to new rectangle. Okay, and we will directly call R1 dot area. System.out.println. I will add line. Similarly, we will create rectangle. R2 is equals to new rectangle. Here I am passing value for length. We will call R2.area method. Okay. Then we'll create one more object with parameterized structure, 2 parameters. Okay. And we will call R3.area. Now we will see how all these gets executed. Sequence of execution. So you can see, as I said, static block will be executed first, then the anonymous block 1, anonymous block 2 for default constructor. Okay, these 2 blocks gets executed for default constructor, and area of rectangle is called. Okay, static block gets executed only once. As per this R1 object, area of rectangle gets called with the default values, that is 10 and 10, because width is 10 we have defined in the anonymous block 2, and length is 10 in the anonymous block 1. Okay, these 2 blocks gets called and default constructor gets called. After setting the values, area method will have the values 10 and 10, so calculation will be 100. Second object where we have called the constructor with single parameter. So for that constructor also, both blocks gets called parameterized constructor with 1 parameter. Here we are setting the value for length. You can check here. Okay, length value is set to 20, which we have passed, and the width value will be taken from the anonymous block 2, that is 10, and the calculation of the area of rectangle will be 200. Then for the third object, we have used 2 parameterized constructor. So for this parameterized constructor, again, anonymous block will be called parameterized constructor with 2 parameters set. Value will be set for length and width, which we have passed, that is 6 and 15. And it will be set to this area method, and it will calculate the area of rectangle with these two length and width values, that is 90. Okay, so the difference between static block and anonymous block is that static block is always executed first and only executed once. Okay, it will never be executed according to your number of objects or instances. It is always executed only once. Anonymous blocks or instance initializer blocks are called multiple times as per your number of objects you are creating and the number of times you are calling the constructor. Okay, so जितने बार भी आप constructor को call करते हो, हर constructor के लिए anonymous blocks call होते हैं, and number of objects, whatever the number of objects you are creating, for all the objects, for all the constructor calls, anonymous block gets called every time. Okay, this is the difference, main difference between instance initializer block or anonymous block and static block. Clear? Any doubt? So suppose we can create a reference variable also here. This is a rectangle, R4 is the object name, and I am giving the reference of R2 here, okay, or R3. I'm using R3. So you can call R4.area method. You will get the same output as the R3 because we are using the reference of this R3. Okay. So whatever the values R3 has, same values will be passed to R4. Okay. This is reference variable. This is a reference variable. It is not an instance. When we say instance, whenever you are using new keyword and the constructor call to create the new memory allocation. Okay. But here this is known as a reference variable because we are referring, we have created the variable or instance, but we are referring the value from another object, another instance. Okay. So all the details will be same for this R4. Same as R3. Okay, so area of rectangle will be 90. Now you can see that the difference is here the anonymous blocks are not called. Why? Because we have not initialized it or we have not called any constructor here. Okay, new memory will not be allocated. We are using, basically we are referring the memory allocation done for this R3 and we are referring that memory. Okay, so it is using all the details same as this rectangle R3 object or instance. Only difference is this is known as the reference variable. It is not an instance. ठीक है, instance हम कब कहते हैं जब आप new keyword के साथ उसको initialize करते हो constructor call के साथ. ठीक है, this is an instance. An instance or you can say object or an object. But this rectangle R4 is reference variable. So this is a reference variable. We are not calling any constructor using this R4 object. We are not initializing anything. That's why anonymous blocks are not called. We are calling the area method. So it is using basically the value set for this R3 object as it is, and it is calculating the area. Okay, clear? Understood? The difference between instance and reference variable as well. Any doubts? So we'll quickly revise all the static details. So first we have seen the static variable. It is all the static variables, methods, all are shared resources. All these are shared among all the instances. Okay, the memory allocation will be only once. It shares a single copy. Okay, it is gets loaded first into the memory at the time of class loading. Static variable value you can change. It will get affected for all the other instances as well. Static variable is also known as class variable. Okay, so if you want to give some common details for all the instances, you can define that variable as static variable instead of defining it as instance variable. Static method is also used to define some common behavior for all the instances. Static methods, also known as class methods, it is also gets loaded at the time of class loading. It is also loaded first into the memory. The memory will be allocated only once. It also has a single copy among, it will be shared among all the instances. It is loaded when the class gets loaded, and one-time memory allocation. It cannot be, it can be accessed using the class name directly. You don't have to create the object of that class. Static methods can be overloaded, but never be overridden. Okay. This overhidden concept we will see in the inheritance concept. Okay. So this is all about static method. So static, we cannot access non-static members from static context, and we can access static context and non-static context from non-static context itself. Okay. So remember all the differences between the non-static and static. We cannot use this and super keyword in the static methods or to call the static methods as well, but we can use it to call non-static method. Static block is mostly used for loading the libraries and library files, native libraries, etc. It is used to initialize the static data members. It is executed before the main method at the time of class loading. It gets executed first in your program, and it is also executed only once. We don't require any memory allocation for this. Okay, the memory allocation, basically, it is nothing but we are writing statements, sequential statements, right? Like we write in the main method. Same statements we are writing into static method, static block. That's why the memory will be allocated if you are creating any members in that. Like with the variable we have created, we are calling a method, then for methods, memory will be allocated. But if you are writing a single statement, we don't require much memory. Okay. And it is also executed in the same sequence which you have written. You can write anything inside the static blocks, complete program also. Okay. In the static blocks, the difference between static block and anonymous block is that static blocks executed only once and at the starting of your program. Anonymous blocks gets executed each and every constructor call. Whenever you are calling the constructors, it gets copied into all the constructors and it will be called the number of times you are calling a constructor. Clear? Understood? Everything related to static. I hope you have understood everything. So this is the end of your module. Next module is your abstraction and encapsulation. So in the next session, we will start with the encapsulation concept first. What is encapsulation? That we have already seen. We will quickly revise what is encapsulation. In the last session, in the last module, we have learned that all the differences of all the four pillars. From that, first encapsulation is that encapsulation is nothing but we are encapsulating methods and variables in a class, or encapsulation is used to hide the data. Okay, wrapping up of data and code together, as well as we are using it for hiding the details of from other classes. Okay, we are hiding the details to provide security to members of the class, and it can be accessed through the methods of the current class. Okay, so this encapsulation part we are going to learn in next chapter. Okay, next module. So encapsulation, we can achieve the encapsulation in Java using access modifiers, that is private data members, and public methods to access these private members. So practically we are going to learn this in the next module. Okay, clear? Any doubts, anyone? Okay then. we will end our session for today here. Thank you, everyone. We will continue in the next session with the next module. But you may leave.